Alright, this is Geometry Chapter 12, Section 1, Tangent Lines. Alright, so what is a tangent line? We'll do it as it pertains to tangent to a circle, but it's not the same. It's kind of the same thing as tangent with sine, cosine, tangent. But you'll learn more about that, where that word tangent actually comes from. It's a similar concept when you take like a pre-calc course where you actually learn what sine, cosine, and tangent is. But it's sort of in relation to a circle. So if we have a circle, we have a point here, 1 point, and then we have a line. And with this line, it's going to hit that circle only at 1 point. Right? It's going to hit that circle as the line comes. It intersects that circle only at 1 point, and it barely touches it at that 1 point, and it's touching it at point B. That's what we call a tangent. In this case, we would say that it's tangent to a circle. Tangent to a circle, meaning that the line touches the circle at 1 point, point B. And the book says it's a line in a plane of the circle. Line of a plane in a circle that intersects at exactly 1 point. Okay, so this line comes across the circle. It only touches it at point B or intersects it exactly at 1 point, point B. We would call that tangent. Alright, tangent to a circle. The line is tangent to that circle. And then the exact spot where it actually intersects at the circle, we call that point of tangency. Alright, so tangent to a circle refers to the line intersecting at point B. Point of tangency refers to the point. Okay, point of tangency refers to the point, and it is the point at which the circle and the line intersect. Point at which the circle and the line intersect. Which leads us to our first proof or theorem of the day, and it's theorem 12.1. And theorem 12.1 says that if we have a circle intersects at point P. So from O to P, so this is our radius. From O to P, and then we have a line that's tangent to O to P. This is line AB. So if line AB is tangent to circle O at point P, then we can say that these two guys are perpendicular. So if line AB is tangent to, this is the symbol for circle, circle and a little dot in the middle, to circle O at point P, then line AB is perpendicular to segment OP. Right. If line AB is tangent to circle O at point P, so here's line AB and it touches O exactly at point P, and I know that it's tangent, then at circle O, then I can say that the point from the middle out, the radius, is OP, and that's going to be perpendicular to that same tangent line AB. Right. If a line is tangent to a circle, then that line is perpendicular to the radius of the point of tangency. Certain definitions to note, just to refresh your memory. Radius of a circle, if you remember, radius is from the middle of the circle out to the edge of the circle. That's a radius. And if you remember, radius is always equal to 1/2 the diameter, and then we have the diameter. Diameter is the distance from one circle that goes right through the center of the circle to the other circle. So this is diameter, this is radius of a circle, and radius is always half of the diameter. We'll be dealing with a lot of radiuses, radii today, and throughout this course, this chapter. This is an indirect proof of that theorem. We're not going to worry about that at all. Okay, so here we have a circle. We have the center at O. We have a diameter that cuts through that. We have a tangent line at D. And then we have an E over here. This is 38 degrees. This is X. They want to know what X is. So here's the deal. Since I know that the tangent line here at point D, right? Remember we said that it's perpendicular. So this guy is 90 degrees. Always. So we know that this triangle sum theorem, the sum of the angles within a triangle is 180. So I know that 90 plus 38 plus X equals 180. So I'm going to subtract 90 and 38 from 180. And I get that X is equal to 52 degrees. And up here they have another example I think I'll go over. Here they have a circle, O. We have 2 points of tangency. So from O to here, and from O here, this is the radius, so these guys are the same distance. And they hit at point L and point N respectively. And they come out here and they come out to a point out here, and that's M. Alright. They have this at 117. They want to know what this guy is. So here's the deal. This is a quadrilateral, right? This actually is a kite. Remember kite? So this guy is 90 degrees. This guy is 90 degrees. So I know it's a quadrilateral. So I know a quadrilateral has 360 degrees when you add up all the angles inside. So we have 117 plus 90 plus 90 plus x equals 180 or 360. Right? And we solve for x. So we're going to subtract 90 and 117 from 360. So this would be 297 plus x equals 360. Subtract 297. X equals 63 degrees. Alright, so this one is a good problem. Alright. This one says, what is the distance to the horizon that a person can see a clear day from an airplane 2 miles above the Earth? And the Earth radius is about 4,000 miles. Alright, so if we have the Earth, we have a radius from the Earth, from the center of Earth out, that is 4,000 miles. What is the distance to the horizon that a person can see a clear day? Can see the airplane 2 miles above the Earth. Okay. So here's how this works. So we have 2 radii. Alright, we have 4,000 here. I'll do this in blue. We have 4,000 here. We have a plane that is 2 miles above the Earth. There's a person over here, and we'll say P for person, who wants to see how it can see from that point out using a pointed tendency. After that, I read from here to there. Right. So on a clear day, how far can this person see this plane? That's 2 miles above the Earth. Okay. So here's how we're going to do this. This is the Pythagorean theorem. This is a right triangle. I already have this distance here, this distance here, this is the hypotenuse. So this is C. This is A, this is B, this is C. So remember the Pythagorean theorem is A squared plus B squared equals C squared. Well, in this case, A is equal to 4,000. B is equal to 4,000 plus 2. And then C, that's what we're looking for. So this is going to be 4,000 squared plus 4,002 squared plus equals C squared. So 4,000 is a big old number. It's a huge number. 1, 6, 1, 2, 3, 4, 5, 6. So 16 billion. Make sure that's correct. Yeah. Plus 16016,004. So 16 billion. 16. I'm sorry, 16 million. I'll get a billion for 16 million. 60 million. 16,004 equals C squared. And that gives me 32,016,004. We're going to square root both sides to get our distance. Would they run around it too? Well, let's find out. We got 5,658 miles approximately. Pretty far distance to see. So you see about 5,000 miles. It's pretty far. Oh, there's an error. My error. It should equal 4,002. That makes sense. So this is, we're looking for B squared. So this. So this is how it should look. That 90 degrees right here. And this is my 4,000. My mistake. That felt wrong. That number felt really wrong. Alright. So 16. So plus B squared equals. Alright. And that was 16. 16. Oh, 4. Alright, so then we're subtracting 16, 0, 1, 604 minus 16. 1, 2, 3, 1, 2, 3. There you go. That makes more sense. B squared. There we go. Then I get that B squared is equal to 1604 square root both sides. There we go. And I get, there we go, that makes way more sense. 126.5 miles. I like that answer much better. Alright, so I drew that circle wrong. We're looking for B, not C. C is given. There we go. My mistake. It intersects over here at point P. There we go. Much better. Much better. Boom. Okay. 12.2 is just the tangent of 12.1, or the inverse of 12.1. So if we have a circle, point O goes out to P, and again we have another line that's tangent to that, and that line is AB. I use way too often. So if line AB is perpendicular to segment OP, at P, which is the point of tangency, and AB is tangent to circle O. Right. So that's the inverse of 12.1. If AB is perpendicular to OP at point P, the point of tangency, then AB is tangent to O. If a line in a plane of a circle is perpendicular to the radius at the endpoint of the circle, then the line is tangent to the circle. Okay, they want to know what the radius is. Circle. We have circle O. We have this guy. We have this guy. I like this in red. This is X. This is X. And then this line extends out. And that's 6. And then we have this guy here. That's tangent to this line, and it's 10. Alright, so remember we know that this guy is 90 degrees. That's X and X, so we have a right triangle. So we can use the Pythagorean theorem. A will be X, B will be X plus 6. We add these two guys together. And then C would be 10. So A squared plus B squared equals C squared. So A is X squared. That's wrong. I made the same mistake. X plus 6 is C squared, because it's opposite of the 90 degree. So A, this is B. Brain's not working. Okay. X squared plus 10 squared equals x plus 6 squared. So this is going to be x squared plus 100. This is going to be FOIL, right? This is the same thing as saying, we can do this in a couple ways. This is the same thing as saying x plus 6 times x plus 6. Then we use FOIL. X times x is x squared. X times 6 is 6x. 6 times x is 6x. 6 times 6 is 36. Combined, we get x squared plus 12x plus 36, which that is. That's one way of doing it. The other way of doing it is, if you remember, a plus b squared is the same thing as saying a squared plus 2ab plus b squared. In this case, a is x and b is 6. So it's going to be x squared plus 2ab, which is x. 6 plus b 36. 2 times 6 is 12, so x squared plus 12x plus 36. They both get you there. Either way. Okay. Alright, these guys cancel. So I'm left with 100 equals 12x plus 36. I'm going to subtract 36 from both sides. That gives me 64. 64 equals 12x. And then I can divide both sides by 12. X equals 64 over 12, and that simplifies to 16 over 3. And that would be about 5.3 bar. Or you can say 5 1/3. Any one of those is correct. I'm more preferable to fractions. Okay. So it says that we have a diagram. We have circle N. Thank goodness, not a circle O. We have NL. So it'll look like this. Is 4. ML is 8. No, ML is 7. And NL is 8. Do we have a point of tangency? So does this point here tangent to circle N? So here we would use the Pythagorean theorem. A would be 4, B would be 7, and 8 would be C. A squared plus B squared equals C squared. If they equal up to each other, does it and A squared plus B squared equals C squared, then we have a point in tangency because it's a right triangle. If it doesn't, then points L is not the point of tangency. Oh. So 4 squared plus 7 squared has to equal 8 squared. So this is 16 plus 49 has to equal 64. 16 plus 49 equals 65. And then this is 64. So they do not equal each other. So it's not tangent. Not tangent at all. Theorem 12.3. This guy says that if we have a circle O, we have a point here at A, and we have a point here at C, and they meet at a common point B. They both meet at the same spot. If that's the case, I'll change that point of tendency. Let me do it like this. Okay. They meet at point C. Then I can say that these two guys are the same distance. So if segment AB or BA and segment BC are tangent to circle O, then those two segments are congruent. BA is congruent to BC. This distance here is the same as this distance here. If they're both tangent to the same circle and they meet at a common point on the outside of the circle, then they are tangent. If two tangent segments to a circle share a common endpoint outside of the circle, then those two segments are congruent. All right. Some definitions. Inscribed and circumscribed. We have a triangle. We have some circle inside the triangle. And the circle and the triangle touches all three. Oh boy. Should have drew the circle first. That's what I should have done. Oh well. Alright, so the circle is going to hit at three different points of tangency. Point A, point B, point C. Alright? And what happens is that it only hits that at that one point of tangency. Exactly one point here, exactly one point here, exactly one point here. We use the word inscribed when this to talk about the circle inside the triangle. So the circle is inscribed inside of the triangle. And remember, this only is inscribed when the triangle only hits at the point of tangency on all three sides. Alright? All three sides. We can say that the circle is tangent to the triangle. Three sides, 3 points of tangency. And when the circle inside of the triangle is inscribed. That's what inscribed means. That they're tangent The circle is tangent inside of the triangle. And then the other way around, right? Inscribed talks about the circle. We have another word, circumscribed. And circumscribed talks about the circle, not the triangle. And the triangle is circumscribed about the circle, meaning around the circle, outside of the circle. So circle is inscribed inside of the triangle. The triangle is circumscribed they use the word about the circle. Okay, can you say outside, right? But yeah, around the circle is what about means. About the circle. Alright, so inscribed, the circle is tangent to the triangle. Circumscribed, the triangle is tangent to the circle, essentially. That's what that means. Okay. Alright, it says point O is inscribed in triangle PQR. Oh man, I should have done nothing with that. I'll take it. Sure, why not? I'll take that. Alright, P, Q, R. So the circle O is inscribed inside triangle PQR. We have points of tangency at point Z, point of tangency at point X, point of tangency at point Y. These guys are common endpoints outside of the circle. So this is the last theorem, right? Common points outside the circle. We are told that this is 15. If this is 15 from here to here, this is also 15 because they share a common endpoint. And the previous theorem says that if they share a common endpoint, then they're the same. So that's 15. Just make this black. Alright. They say that this from here to here is 17. Since they share a common endpoint from here to here, this guy here is also 17. Because they share a common endpoint at P from the point of tangency. So from Y to P and Z to P, they're the same distance. So they're 17. They want to know what these guys are up here. What is this guy? What is this guy? I don't know what they are just yet, but I do know that they're the same distance. XQ and YQ are the same distance, so I'm going to call it X. Why would I have another X next to an X? Oh, that's just horrible. Okay. I do know that if I add all of this up together, they tell me that the perimeter is 88. So I have a perimeter of 88. So if I add all of these guys up, I get 88. So 15 plus 15 plus 17 plus 17 plus X plus X. That's going to give me 88. So I add all these guys together. So it's what, 30 plus 34. I got 64 equal or plus x is 2x equals 88. Subtract 64 from 88. And I get that 2x is equal to 24 divided by 2x is equal to 12. So this guy is 12 and this guy is 12. Alright, that's this section. Hope you have a great rest of your day.